So now we're going to take a look at cotangent and tangent values. Once again, it's all based on our sine and cosine values. So there's an identity for cotangent and tangent that we're going to want to be very familiar with to help us calculate some values. And if we're getting stuck and we need to actually figure out the values, we can do this every single time. We're going to look at some tricks too to know the values pretty quickly as well. The cotangent is defined as the cosine of theta divided by the sine of theta, where the tangent is defined as the sine of theta over the cosine of theta. So just like we did with secants and cosecants, we're going to plug these values into our functions, our new identities, and calculate some things. We're going to have to do a little bit more work, though, than we did with secants and cosecants, because there we were just finding the reciprocals. Here we're taking two values and comparing them. So if I look at 0 degrees, I've got a value of cosine is 1 and the sine is 0. If I start calculating the cotangent value, I'm going to take the value of 1 divided by 0, which again, we know that's going to give me an undefined value. Versus tangent, I take the sine over the cosine, so I'm essentially flipping that fraction. I'm going to have 0 divided by 1, which will give me 0. You might be able to guess what happens at pi over 2, but we'll get there when we get there. Pi over 6, we're going to take the value of cosine, which is root 3 over 2, and divide it by 1/2, and that is gross. So again, we don't really divide fractions. What we're essentially doing is taking this and making it a multiplication problem. And by doing that, what happens is these 2's are going to cancel out, and I'm going to be left with just the square root of 3. And so that's going to be my cotangent value at pi over 6, the square root of 3. But what happens when we take that fraction and we flip it? What if we had 1/2 over the square root of 3 over 2? Well, that's going to be a little bit more complicated to see. The 2's again will cancel. I'll have 1 divided by the square root of 3, which again, it's right, but not what we're looking for, because what we want to do is rationalize that denominator. So I'm going to take that square root of 3 and multiply the top and bottom by that to cancel it out, giving me the square root of 3 over 3. So the tangent of pi over 6 is root 3 divided by 3. And the pi over 4's, if you look at the sine and cosine values, I'm not going to set this fraction up because I just want to take a look at it. When we have the cosine values and the sine values are exactly the same. If you're taking any number and you're dividing it by itself, you always get 1. So the cotangent of this value has to be 1. Same with the tangent. We take the sine over the cosine, the same thing over itself. It's got to give you 1. So that's nice. The pi over 4's are awesome because they're just going to give you 1 for the cotangent and tangent values. Now we already know what we could probably predict anyway. What's going to happen at pi over 3, just like we did with the sines and the cosines, the secants and the cosecants, things are going to switch because you're switching the sine and cosine values. So when we had the values at pi over 6, our coordinates were cotangent was root 3, tangent was root 3 over 3. That's going to change when we get to pi over 3. It's going to become root 3 over 3 for the cotangent and the square root of 3 for the tangent. They're flipping around. All right, now what about pi over 2? Well, as we probably guessed, it's going to be the flip of what we have at 0. Let's just double check though. If I take the cosine, which is 0 divided by 1, yes, I do get 0. If I take the sine over cosine, 1 over 0, the tangent value, that's going to be undefined. And yep, exactly as I expected. At 0 and at pi over 2, those coordinates changed locations. So let me put these values into our unit circle so we can start doing some things with them. And start looking at the other quadrants, which is going to change things a bit for us. Oops. Helps if I write them correctly. And then pi over 4's are 1 and 1. Yeah, that's a great looking one. And then pi over 3 is root 3 over 3. And root 3. All right, cool. So when we're looking at the values in the other quadrants, we are going to have to keep in mind what the values of sine and cosine are, whether they're positive or negative. But instead of just saying, oh, well, the cosine's negative in this quadrant, so the cotangent should be negative as well, it doesn't quite work out that way. We want to know effectively, do the cosine and sine have the same value, or same sign, S-A-G-N, or different signs? Because if they have the same sign, then if I take a negative divided by a negative, or a positive divided by a positive, I end up getting a positive value. But if they're different signs, if I take a negative divided by a positive, or the flip of that, I'm going to get a negative value. My end result would be negative. So when I'm looking at whether cotangent or tangent are positive or negative, I need to know, do the sine and cosine have the same sign, S-I-G-N, or are they different? If they're the same, then my cotangent and tangent will be positive. If they're different, then my cotangent and tangent will be negative. So looking at that, quadrant 1, I'm definitely positive all the way through, but quadrant 3 is actually where I'm positive for cotangent and tangent, because both of those values for sine and cosine will be negatives. In quadrant 2 and 4, I'll have negatives because the sine and the cosine are either positive and negative or negative and positive. So it's the same idea with the values, though. I'm still going to take those and bring them over, but I'm just more careful with my signs, S-I-G-N. So let's say we had our pi over 4s, and I went into quadrant 2, which is 3 pi over 4. Again, in quadrant 2, the cotangent and tangent will both be negative. If I go to quadrant 3, let's say I take that pi over 6 value. When I went to 7 pi over 6, now I'm actually positive in this quadrant. So it's root 3 and root 3 over 3, just like we had in quadrant 1. Both of them become positive because I'm comparing sine and cosine. Versus quadrant 4, where we're going to be negative, because one of those is negative and the other one is positive. So at pi over 3, my cotangent would be root 3 over 3, and my tangent would be root 3. Now there's a quick, easy way to remember. Like if you know that at the pi over 3s and the pi over 6s, we're going to have a root 3 over 3 and a root 3, and figure out which is which, the key is going to be looking at your tangent. So if you look at our fraction here, root 3 over 3, 3 and 3 together gives me 6. Every time I have a denominator of 6, my tangent is going to be root 3 over 3, or negative root 3 over 3. If I'm looking, oh, you know what, I messed that up. Sorry guys, those are both negatives. Sorry. Just looking back and finding my mistake there. A denominator of 3 would tell me that my tangent would be just root 3. So even if I went over here to 2 pi over 3, I know that the tangent is going to be negative root 3. Now, if I went back to my cotangents, it's just the opposite. So if the tangent is going to be the root 3 over 3, my cotangent is going to just be root 3. If my tangent is root 3, my cotangent is going to be root 3 over 3. Now the pi over 4s, love those. Those are easy. They're always going to be either 1 or negative 1, depending on what quadrant you're in. Positive, negative, positive, negative. All right, so positive here, positive, and then negative. So those are some quick ways we can easily know our values. And again, for the undefines or zeros, I like to think about those values because I don't want to memorize a little bit of a trick here and then get it wrong, because then they're always going to be wrong. Just start thinking about, well, is the cosine 0 or is it 1? Is the sine 0 or 1? And that can help your fraction out to get the tangent and cotangent values.